right, hello and welcome to another episode of Aether Cosmology. I think tonight's the reading roundtable. So we're going to be reading a paper by Stephen Crothers. I'm going to join the group here in a second. But this is going to be a review on gravitational waves and what they claim to be measuring. So we're going to look into the source of what a gravitational wave even is. So let's get into it. All right, hello. I'm live with the panel of Aether Cosmology, dude. We got Pizio, Clearview, Crease, Phonon, Monon, Toby, and Shane. All right.
Yo.
So I just gave a little soft intro there on LIGO and what we're going to be getting into, what exactly it is they claim to be measuring. And I put together a little presentation on Crothers' papers, specifically the mathematical part, because it's a little dense, but it's super important because the whole mythology of how relativity works and all that is based on covariance with the mathematics system. So if something like a gravitational wave is claimed to be, propagating at the speed of light, and they're accepting it as like a law of physics in that regard, because that's actually why the propagation rate is set at c, so that it could have that like aesthetically pleasing, look to it, where it's like, oh, look at this, like nothing goes faster than c, and Einstein predicted it and all this stuff, right? So it like tracks for them. This is hugely important for them. So if this gravitational wave were to be, physically meaningful in their equations, even in their lore, it has to be called covariant, meaning when you transform it or use a different coordinate system, the speed of its propagation has to remain the same way that light, the same way that light is invariant under transformation. They say it's a constant, right? So when you have laws of physics and you transform them in a coordinate system, those laws of physics have to be the same, right? And that maintains a covariant relationship. So we're gonna analyze, or we're gonna go through Crothers' work where he analyzes the covariant relationship with gravitational waves and coordinate systems. All right, is there anything that you wanted to add, Toby?
Yo, are you presenting something?
I'm about to, yeah.
Oh, cool. No, nothing else really to add. I will just real quick housekeeping. This is our first time streaming on Rumble if it's working. And if you're tuning in, this is reading night. We do this on Thursday nights. This is reading and research night. Typically we just read a paper, but also sometimes we do active research. But it's not so much about entertaining you, the listener. It's more about giving you a window into how our learning and research process goes. Tonight, we are going to have a very short presentation from Alan about Stephen Crothers' paper, and then we're going to do a quick little read-through skim through Crothers' paper itself, and then just maybe talk a little bit about that and about the convolutional neural networks that they use at LIGO. But yeah, with that, go ahead, Alan.
All right, let me make sure you guys can see this. You guys see that okay?
Yep.
Fantastic. All right, let me grab some water.
I see Wizard Einstein in a purple hat robe looking like a mathematical black hole as a monster from the sky. Is that what I was supposed to be looking at?
Some sort of sky prophet making a mathematical prediction that can't be disproven either way.
Looks like a sky demon that he's casting with his mathematical wand. Okay, I'm just making sure.
Yep. So this is LIGO, the Big Charade. So this paper is by Stephen Crothers, which we're going to read here in a minute. So I'm not going to read too much on it, but this is the premise of this paper is that LIGO claims that they've measured a black hole. So Crothers gets into what even is a black hole, right? So it's a mathematical construct born out of Einstein's field equations, and what they say happens to what happens when certain conditions are imposed on celestial phenomenon, right? So what they say basically for a black hole to happen is that a celestial object has to reduce its size, or has to reduce its size by 10 solar masses or whatever, right? It has to reduce down to basically 10x the size of the sun. And these things are like way bigger than the sun, right? So when they reduce down, that's when these equations break down. And instead of going like, oh, okay, well, this is like the limit of the equations, they mythologized it and turned it into like a story, like they have a little story about it. So when the equations break, they say, oh, Well, that's when space-time collapses in on itself infinitely, and that's where a black hole is born. And then they talk about the event horizon, the what happens to the black hole, what happens inside the black hole, the radius, and all that stuff. It all comes from these from from the solution to these field equations, and then when they apply them in, they break down, right? Like when they hit their limits, essentially, right? So then they just turned it into another story. So to give some context on what these equations look like, or what the field equations look like, they're in their tensor form. So we got G sub UV, R sub UV, and T sub UV, pseudotensor, Ricci tensor, and the Einstein tensor, which we'll get into in a little bit. But if you Google like Einstein's field equations or what they look like, this is their like the modern form, right? So we got the GUV lambda, the small GUV equals 8 pi G over C C cubed, or what is it when it's forward, Stone? uh, anyway, and then TUV. So what we have here is we have the space-time metric, the space-time metric, the GUV. We have lambda, which is the cosmological constant. So when they need like dark matter and dark energy to fix things or change the influence of a metric or balance things out, they hit up your boy lambda. But anyway, GUV right here is the dimensions of space-time, and this allows them to derive angles and stuff, or angles between celestial phenomenon. So they'll take like, they say it's like a sphere, right? So they'll take an angle between the center of it and the polar axis, and they'll draw angles through it that way. So this is like the coordinate system metric for where that measurement's going to take place. And then GUV on the left side is the gravitational field. So the gravitational influence and how it's going to affect that space-time metric. And the 8 pi GU over C4 is the distribution of space of that gravitational field, of that energy, and how that's going to relate to the TUV, which is the conservation of energy and momentum. So there's going to be, so that's how the equation works. That's the description of it. And inside of that, the quote unquote solutions for these, right? Like the Schwarzschild metric, for example, or the Kerr metric, which is what LIGO claims to be measuring something out of. Allow for certain conditions and allow them to make, certain measurements. So when they do that, those conditions obviously have limits. And then when those break down, they say, okay, well, this is the black hole event, right? And then they turn it into a whole thing. So what we're going to be looking at with LIGO is going to be something called the Kerr metric. But before we get to the derivation of the black hole gravitational wave itself, for the concept of that, an important part of this is covariance. So earlier when I was talking about the covariant relationship with the mathematics and transformations and stuff, so these field equations here, right, these give birth to metrics that describe the dimensions of space-time and how they're affected. Is it flat? Is it curved? Etc. Right? So all of those coordinate systems should be the laws of physics should be invariant under transformation. They should all be the same in order for these equations to make sense. So they have to maintain that covariant relationship, and that's what that is. Okay, so invariant is when a quantity remains unchanged under transformation. So, for example, the speed of light, right? F equals ma. Any law of physics like that has to be invariant under transformation. Oops. And tensors, those are the objects that represent the relationship. So the GUV, the little GUV, all that, those are tensors. And the little UVs are indices. So those are basically just little matrices that describe the coordinate system. From my understanding, it's basically like little pockets of infinity, and you can draw your dimensions for your event inside of that coordinate system.
Oh, of course.
Essentially. All right, and let's see. So the tensors, the pseudotensors. So a pseudotensor is like an object that. So the way that Einstein had to satisfy the conservation laws, with energy equaling mass and all that, he had to satisfy it with a pseudotensor. But that's a whole separate issue. I'm just going to kind of breeze through the rest of this. Let's see. Okay. So we'll read about LIGO in depth here. So I'll skip through this. This is the introduction to the paper, but I already went over the history of the gravitational wave and how they're deriving it and whatnot. So we'll get right to the propagation speed issue, right? So they say that based on these equations, when they solve them, that they that there's a an amount of temporal displacement that will be rippling through the universe that's based on the magnitude of a celestial event, right? So in this case, they say that two black holes, which are derived from a Kerr metric, they say that those will collide, and that space time will ripple out in perpetuity, right? And they say that they're going to measure this with linear interferometry. So they have an orthogonal setup, and they say you can't measure motion with that, right? You can't measure the orbit of the Earth with that. But what you can measure is a ripple in time from an event that happened 11 billion years ago based on our mathematical derivation and covariant relationship. And that's and and if you question that, then you're a fool. Okay? So we'll just read a little bit here, and we'll go over the equations used and talk about what Crothers shows in the paper on the mathematical dense end. So the impression, okay, let me read through here. Sorry about that. Okay, so the LIGO Virgo collaboration opened their introduction papers with the following. In 1916, the year after the final formulation of the field equations of general relativity, Albert Einstein predicted the existence of gravitational waves. He found that the linearized weak field equations had wave solutions, transverse waves of spatial strains that travel at the speed of light generated by variations of a mass quadrupole moment of the source. So that's what he found when he linearized his field equations. And from my understanding, his field equations are non-linearized. So to solve them, they have to make like broad approximations. So they linearize them in that regard, so that they can actually do the math on them. Otherwise, it would be impossible. Okay, so he goes on to say the impression given here is that the speed of propagation of Einstein's gravitational wave is uniquely that of the speed of light in a vacuum, and that's false. The propagation speed of Einstein's gravitation wave is arbitrary because it is coordinate dependent. That Einstein's wave seems to travel uniquely at the speed of light in a vacuum is simply because the speed of light was deliberately selected in order to conform to the presupposition. The method employed to determine the wave equation for Einstein's gravitational wave is the weak linearized field of his field equations in concomitant. No, what is that? Concomitant selection of the set of of the specific set of coordinates. Maxwell's electromagnetic theory predicts sinusoidal electromagnetic propagation in a vacuum at a unique speed v given by this equation. So v equals 1 over the square root of epsilon sub 0 and mu sub 0 equals the speed of light. So the speed of light in a vacuum here is measured in henries per meter and farads per meter for the epsilon and mu. So the electric permittivity and the magnetic permeability of free space, like in a vacuum, right? So that's the speed of light with the impedance, with that impedance. And there is an impedance, interestingly enough, in a vacuum somehow. Okay, so let's see. We got the speed of light changes accordingly to the permittivity and permeability of the dielectric medium in which it travels. V equals, same equation as last, equals C over the square root of K times K sub M, where K and K sub M are the dielectric constant and the relative permeability, respectively, of the medium. Note that the speed of electromagnetic wave propagation in a vacuum is not arbitrary. Since the speed of light in a vacuum plays a central role in Einstein's theory of relativity, the motive for choosing the coordinates in order to make the gravitational waves emerging from the linearization game travel at the speed of light in a vacuum is abundantly clear. So let's see here. Appendix A. So he gets into, so he shows what he means in Appendix A. Appendix A presents the mathematical means of the linearization of Einstein's field equations, revealing the arbitrary nature of the speed of his gravitational waves. Okay, so the rules of the linearization game are as follows. A, h sub uv together with its first derivatives h sub uv comma p and its higher derivatives are small products of these are ignored. B, the suffixes raised and are lowered at n superscript uv and n subscript uv rather than g superscript uv and g subscript uv. So Foster and Nightingale. That's something in regards to the in regards to the linearization game. So basically, just making the field making broad approximations so that they could solve the field equations, right? So that's basically what they're saying there. Let's see, blank slide. Okay, so we get to the appendix now, and we'll read here. So it says, Einstein's gravitational waves are extracted from this linearization of his nonlinear field equations. Accordingly, the metric tensor is written as g subscript uv equals n subscript uv plus h subscript uv. So where h uv is much less than 1. Yeah, it's much less than 1, and n subscript uv represents the Galilean values 1, -1, -1, -1. In the linearization game, h sub uv slightly perturb the flat Minkowski spacetime. The GUV equals n sub uv from its flatness. So suffixes are are raised and lowered to the h uv and the n uv. Here, the h uv and the first derivatives are here, and he gives the coordinate system here for that, and the higher derivatives are the small product of them are neglected. So basically, what he gets on to say here is that these are really small perturbations, and to make the approximations, they would just get canceled out. But if you use a certain coordinate system, you can actually the effects will maintain, and you'll get the they'll propagate at c, and they'll give the appearance of being like meaningful, right? So to recap here, the NUV is flat space time. The HUV is a perturbation in the back is a perturbation, right? So it's the gravitational wave, it's the event being described. The GUV is the original space-time metric, and the R, let's see, yeah, when he gets into the Ricci tensor, the RUV is how much space-time will be curved, and that's defined by the geometric properties of the space-time metric that's chosen to describe it's basically the coordinate system that they're using to describe where the event's taking place, right? So when they use a flat space-time metric, they're like, okay, cool, we get gravitational waves propagating at c, but when Crothers goes through, does all the math, and uses the original space-time metric, right, the perturbation vanishes. So when they get in here to this, I forget what this is called, but this is where their linearization approximation thing. So when they do that, that's called wait, I think I have a note on it. Yeah, right here. Nope. I don't know. It'll be in the next section. But anyway, when they do that, that is when it's being linearized. So the event that they claim is being measured would go to 0. It doesn't exist, right? But because they did it, it's the Allenbatarian operator. So that's what that is. So anyway, when he does that, the event can't even be measured. It wouldn't exist. So they're using a preferred coordinate system to do their measurements. When they say any coordinate system should be preferred, and especially if this thing is going to propagate at the speed of light and be a gravitational wave and all that, and be a consequence of relativity, it should definitely it has to be invariant under transformation, and it's not. So that's pretty much the summary there. So we'll just read on. So which equation A10 describes the wave propagating at the speed of light in a vacuum. However, the crucial point of the foregoing mathematical development is Einstein's gravitational wave does not have a unique propagation speed. The speed of the wave is coordinate dependent, as the conditions of equation A6 attest, and the constraints of equation A6 selects the coordinate system to produce the propagation speed. A different set of coordinates yields a different propagation speed, as A3 does not have that constraint. Uh, so basically, the amount that it's curved or flat that they start with. So Einstein deliberately chose a set of coordinates that yields the desired propagation speed of that of light in a vacuum. So the speed of light, in order to satisfy the presupposition that the propagation speed is that of c. There is no a priori reason why that particular set of coordinate selection should be better than any other. The sole purpose of the choice is to obtain the presupposed result. And then he goes on.
No, he can't be right about that. I thought relativity was how we made all our predictions.
Well, it turns out the homie Arthur Eddington knew about this too. So he goes on. So he goes on to quote Eddington. He says, all coordinate systems differ from Galilean coordinates by small quantities of the first order. The potential GUV pertains not only to the gravitational influence, which has objective reality, but also to the coordinate system to which we select arbitrarily. We can propagate coordinate changes with the speed of thought, and this may be mixed up with the more dilatory propagation discussed above. There does not seem to be any way of distinguishing a physical and a conventional part of the changes of the GUV metric. So the changes in the space-time metric that describes the geometry of space-time. So the statement that in the relativity theory general gravitational waves are propagated at the speed of light has, I believe, been based entirely upon foregoing investigation, but it will be seen that it is only true in the conventional sense if the coordinates are chosen to satisfy a certain condition which has no clear geometric importance, and that the speed of light, if the coordinates are slightly different in the speed altogether different from that of light, and the result stands or falls by the choice of coordinate systems. So and so far as can be judged, the coordinates here used were purposely introduced in order to obtain the simplification which results from representing the propagation as occurring with the speed of light. The argument that follows a vicious circle. Eddington. Citation 38 and 57. All right.
Wow.
Yeah, so huge they got the desired result. Like, they always say like, oh, confirmation bias and all this stuff, because a big part of this is that these are abstraction or, mathematical abstractions. And they're saying that a mathematical abstraction that happened 11 billion years ago affected a temporal pocket in time that rippled out in all directions. And they're actually measuring that. And it's not even covariant with their formula or with their structure, with their belief system. Like, it has no physical meaning. Like, even if there was a measurement that they do match to this that we're gonna go over, these measurements and what they're doing with them. Even if there was a measurement, you couldn't even say it was due to this event, because it has no covariant relationship with the formula from which it was derived. All right. So I think that's it on that. Let me figure out how to close this out here. All right. Let's see. There we go. All right. That's my mathematical interpretation of the
You know what? I choose to believe it's real, so it's real to me.
Sorry, that's the mathematical analysis.
Mathematical abstractions are where I live. They comfort me. So
Yep. And sorry if my audio was off. I might have been out of position on that when I was reading.
You're much louder
just
now, but
only
it
at
wasn't
the
bad.
end.
Oh, only at the end. Okay. All right. Cool.
Yeah,
Cool.
and then I just turned you up on my end, and it wasn't too bad.
Okay. Cool. My bad. Yeah. If that ever happens, just let me know because I move around sometimes when I'm talking and shit.
And so real quick, I'm gonna drop 2 papers. Indio sent a video to check out that I'm gonna check out. In that video, I didn't have much time to watch it, obviously, because you were talking, but it links these 2 papers that look interesting.
Nice.
And then also,
I think you dropped the same one twice. No.
oh, are those both the same?
Degeneracy
No,
of
they're
the
different file
gravitational
sizes.
form. What's happening? Oh, you're right. My bad. Okay. Never mind. The issue was me.
So let me see. I think I had a couple of other random highlights maybe that we could check over real quick.
Yeah, it sucks they can't measure linear motion or anything like that, or anything that fluctuates with sidereal time, but they could
They
measure
can't
temporal
they
pockets
can't
that ripple from 11 billion years ago.
Yeah, it's crazy how that works, man.
Yeah. And I don't know,
It's actually
Toby,
quite impressive.
you got to add what is it called? The information paradox to the list of paradoxes, bro. So part of
Oh, we got another one, huh?
yeah, the early confirmation of black holes was the was the mathematical derivation of something called Hawking radiation. So when they say Stephen Hawking proved Hawking radiation, you're like, what? No way. Did he get out there with his wheelchair and measure it? No, no. He calculated the probability of its existence, and like, what exactly does that mean? So in the mythology goes as follows: there are little what do they call them? I can't remember the name, but anyway, these things just pop in and out of existence, right? And there's a real portion of it, and there's a virtual representation of it. And in a black hole, or if this event happens, one of these things spontaneously comes into existence. Um, the real version of it will get sucked into a black hole, and the virtual particle won't be. Oh, I'm sorry. I'm sorry. These things pop in and out of existence, right? And the virtual particle of it collides with the real particle of it, and it deletes like really quickly, right?
But
But yes, it's like that. I forget the name of it, but if this happens next to a black hole, right, the real particle of it will get trapped in the black hole, and the virtual particle won't be able to self delete, and then it'll get like reflected back from the black hole, and they call that emission Hawking radiation. Now that's never been measured, never been seen. No one's ever touched it, smelled it, breathed it, measured it, or anything. But Stephen Hawking used math to show that the probability that that could happen based on that self deletion process, right? If it happened next to a black hole at a certain magnitude, right? That would happen, and it would be like that's the prediction that would happen, that it wouldn't be able to self delete. So that's what they call Hawking radiation, and that produces that's like, so the confirmation of black holes, like the singularity and all that, gets into the information paradox. It's been a while since I've delved into it, but that's like an early introduction summary of what they say is going on with it in Hawking radiation.
Wow. Okay.
Yeah, it's
that's
a
incredible.
yeah, it's a doozy. I actually have I did a video on it a long time ago on my channel. Yeah, it's crazy, man. And there's this debate where there's these 3 physicists, and they're talking about they're having a debate on the information paradox and black hole and quantum mechanics, and like it just dude, the paradox like destroys all of their paradigms, and like they couldn't even argue it, like they couldn't even argue it to completion, because it like refutes their entire paradigm. So really interesting paradox to look into.
Yeah, I'm gonna have to add. I literally added it to the list, so
Yeah,
I'll definitely be looking into it.
I'll pull
How
up
long is the paradox list?
I'll pull a link
Let's.
up
So I'm
here.
gonna read through it here. We got.
I mean, how
Let's
many?
see. We got. Let me collapse this.
So here's
We got the particle wave duality twin paradox, Ernfest paradox, the Einstein-Podolsky-Rosen paradox,
Ooh, that's real.
Schrodinger's cat, Heisenberg uncertainty, and then the Newman-Seliger gravitational paradox, and then now the
Nice. All the good
information
paradox.
paradox.
I think we should get like an even dozen paradoxes and then pursue them all at once.
I'm putting a presentation together.
Are you gonna take them all at once? Or are you gonna
Yeah,
do one at a
it's
time
called
and do the
paradoxical
whole year of
Einstein.
paradoxical presentations?
You might be onto something about not doing them all at once.
You know how your theory to explain physics and reality and cosmology is super correct?
Yeah.
When it's riddled with infinite paradoxes.
Well, yeah, right. Or mathematical how about if you have to correct it constantly for things that don't scale covariantly? That's probably a good sign too.
Yeah. Or how about you just trick everyone that doesn't like follow up on the math and they get super pumped. They're like, "Oh, no way, Star Wars, Tatooine, here we come." Like nobody bothered to check to see if anyone, dotted the I's, carried the 3 or whatever.
Is that why your thumbnail was Einstein in a wizard hat creating a black hole with a magic wand? Because that seems aptly fitting now.
Yes, that's exactly why.
Gotcha.
So yeah, just running through my highlights real quick. The reported detection was obtained not during an observation run of LIGO, but during an engineering test run prior to the first scheduled observation run on the 18th of September 2015. They said it matches the waveform predicted by general relativity. So basically, yeah. Let X be a black hole universe. Let Y be a Big Bang universe. They pertain to completely different sets of Einstein field equations, and so they have absolutely nothing to do with one another. So basically, they can't coexist. So that's like fallacious and not logical. These equations do not permit the presence of more than one star or planet in the universe. I can't remember why that logic.
It was the curvature of space time. It has to do with the imposed curvature. Different metrics.
Black hole universe is a solution to a specific set of Einstein's nonlinear field equations. It is not possible to extract from it any gravitational waves that are produced from linearized field equations. Superposing solutions obtained from the nonlinear system with those from the linearized system violates the mathematical structure of general relativity. Nonetheless, the LIGO-Virgo collaborations superpose everything.
Yep.
Wait, what?
Yeah.
Superposes everything. Wait,
So scroll up.
Nonetheless, we'll just decide.
So let's show the graph a little bit. Or so these gravitational waves that they're saying that they've derived, right, are based off of uh what is it? The Schwarzschild radius. Actually, these ones should be off of the Kerr metric because they're moving. But Schwarzschild radii, the effective velocity given. That's crazy, dude. So they input the mass of an event, and then they're like, okay, if this happened, there would be a ripple in space time that would look like this. It would match this frequency on an interferometer.
And then they got that result.
No, wait till Toby gets to how they to the breakdown of that.
Impression given here is that the speed of propagation of Einstein's gravitational waves is uniquely that of light in vacua is false. Propagation speed of Einstein's gravitational waves is arbitrary because it is coordinate dependent. This speed was deliberately selected in order to conform with the presupposition, as Alan eloquently stated earlier. The speed of light changes according to the permittivity and permeability of the dielectric medium in which it travels. Shout out Crothers. K and Km are the dielectric constant and the relative permeability, respectively, of the medium. Each and every black hole is an independent universe by its very definition. its space-time extends infinitely far from its singularity, as Alan was kind of putting it earlier, like little pockets of infinity. Without the asymptomatic condition, the black hole equations do not result.
So right,
Skip this
without
one.
imposing a condition on the metric that violates it, and they don't even get a black hole. They essentially, I think this he goes over at some point in here. They literally get to the point where they are essentially dividing by zero, and they're like, "Hey guys, this is the singularity."
Science.
Yeah,
Just
we
just to
There are
think there,
forces in.
we
Go
measured
ahead.
it dividing by
this
zero, dude.
dude, there are people out there like in Discord servers who hold this thing and this experiment and this detection like so sacred. Just think about them.
I think
There are
these
forces.
waves move at the speed of science.
Absolutely.
There are forces in general relativity, but gravity is not one of them because it is space-time curvature. It immediately follows that according to cosmology, gravity is infinite at a black hole singularity. That's a pretty important note. However, no finite mass possesses zero volume, infinite density, or infinite gravity anywhere. The Schwarzschild solution has no physical meaning because it is the solution to a set of physically meaningless equations. Furthermore, all black hole equations are obtained by violations of the rules of pure mathematics, as will now be proven. Oh yeah, it just says the speed of light in vacuum is set to unity, singular.
Those good old pure mathematical violations, as Alan would say.
We have a lot of those though.
Just disgusting, bro. Just every time they were like, "Show your work," like, dude,
Well,
they don't have to do it for this. Everyone's just like, "No, submit." And then,
According to
and then we can.
cosmologists,
Sorry, yeah, go ahead.
oh, go ahead.
No, we can end on that note. I'll save it.
So, according to cosmologists, the Schwarzschild radius or gravitational radius is the radius of the event horizon of a black hole. That R is incorrectly treated as the radius by cosmologists is most clearly evident by the very Schwarzschild radius, which for stars lies buried deep in the stellar interior. Notwithstanding, R is neither the radius nor even a distance in any black hole equation, a mathematical fact which subverts the entire theory of black holes. Thus, the Schwarzschild black hole is invalid because it violates the rules of pure mathematics. It requires the square of a real number to be less than zero. The same violation of the rules of pure mathematics produces all of the black hole universes. Although one violation of the rules of pure mathematics is sufficient to invalidate it, the black hole validates other rules of logic. Einstein maintains that although it contains no material sources, a material source is nonetheless present in order to cause a gravitational field. Huh. Isn't that cool?
Dude, those thought experiments will get you, bro. Like, it sounds cool in your dome, but when you put it to pen to paper, it's like, oh well, oops.
According to Einstein, his equation contains a massive source at the origin. Yet also, according to Einstein, from which 109A equation is obtained, contains no material source. This contradiction is readily amplified,
you know,
easily
what
reaffirmed.
it reminds me of is like those virtual photons when they couldn't explain stuff. They'd invent particles that would appear when they needed to, disappear when they weren't, and they would like, "Yeah, don't worry about it. It works. No mass, kind of mass has a charge. It's fine." Okay, and then they just go, "Yeah, yeah, that's fine." We'll just make up the framework, the rules, and the evidence as we go along.
Yep. And then we'll just swap in a metric, dude, that satisfies whatever conditions we need. and most people don't know anything about that. So we'll just tell everyone that the measurements that we get out of that will reify everything. And if you ever
They get
question us, like, we'll make sure you don't have a career.
question. They get excited. Oh my god! They found another one. Yes.
Dude, a gravitational
Can I hold the
wave, right
pause
where
button
right
down?
where we were looking for.
Right,
Yep.
right where I put the data. That's crazy.
What's up, Stone?
Can I hold the pause down just for a second? I wanted to address a statement that went by pretty quick about 2, 3, 4 minutes ago when Toby was reading, or I think so, yeah. Mentioning about how they were defining the event horizon in terms of the gradient about its power to inwardly pull, and saying that that is the point where gravity becomes infinite. I don't know. When I first learned about them, it seemed like they wanted to use a definition that revolves more around how at that point light can no longer radiate from that body, that the forces of itself are pulling inward so strongly that again we think it in terms of how light cannot propagate through that space beyond that, I guess, radius. And you're saying the radius that doesn't exist, and they're correct that this is more like a field calculation radius where, quote, gravity goes to infinity. But I don't really think that's what they're trying to bang at. I think this paper is a little on the aggressive side.
Oh,
But
it's super aggro
it's
because they
yeah,
actually
really
the
harsh, really
situation you just
harsh.
described with the radius, they use it for like two different ways.
Yeah, I hear him slamming it to the wall sometimes where that's really not founded or called for, or even
Yeah.
fully explained.
when,
You know what I mean?
yeah, when we're done reading
Just thought
this,
I'd point that out.
yeah, when we're done reading this, I was gonna recap his career, what happened to him, why he's so jaded.
Gotcha. Carry on.
Yes, sir. But yeah, he does have a little spice to him, huh?
Yeah, I love the sass.
Dude, he challenged the leader of the International Gravitational and Space Time Relativity Committee to a fight. So, like, you know,
I think that just makes him easier to take down. If he had taken a more, solid approach to this and
oh he
moderated his
oh
Dude
he
was pissed.
castration
dude
a
Dude was
little,
pissed.
he,
oh
he would have
dude
gotten farther.
wait till I go over the story, bro. He tried that.
Meaningless collection of dude. He totally figured it out. Pseudotensor, meaningless collection of mathematical symbols.
The mathematical error is profound, but completely unknown to cosmologists. Einstein's pseudotensor is a meaningless collection of mathematical symbols. Contrary to Einstein and cosmologists, it cannot therefore be used to represent anything in physics or to make any calculations, including those for the energy of Einstein's gravitational waves. Nevertheless, cosmology calculates.
Yep. And what
Pretty
he's
funny.
talking about there with the pseudo tensor, to touch on real quick, that's that first order intrinsic differential invariant thing that I talk about from time to time. So to satisfy the conservation laws, Einstein actually had to derive the pseudo tensor from the gravitational field tensor. So it's basically like he's satisfying the conservation laws within the field that's creating it, but like dimensionally with the structure or whatever math, you can't do that. It's supposed to be derived from the field equations, or the sorry, the yeah, from the field equations.
More specifically, you're talking about a
Hey, real fast.
pseudo-gravitational
Sorry,
sensor?
real fast. Sorry about this,
Pseudo-gravitational
but
tensor? Anyways, go for it.
I'm just asking. Does someone in here know Bob the Science Guy's real name? Jaren's like spamming the group.
Oh, the science.
Well, hey, we are live,
Um,
so let's not be dox. If he's not
Oh, okay, no,
public,
I'm
then
sorry.
let's not dox him. But if someone wants to like
My
message
bad.
you or
Continue.
whatever,
Yeah,
No, sorry.
cool,
yeah,
cool,
what were you saying, Stan?
I didn't even realize we were live. My bad.
all good. So moving on.
Stone, what were you saying?
You there, Stone?
Oh, yeah, no, I'm still here. I was just actually tossing around on the left side here for a bit while you guys get back into gear.
Cool.
Geez, what did I say?
Something about the pseudo tensor. It was a question
Oh,
about that.
Oh, yeah, I just wanted to clarify about the terminology that is in regard to specificity, that when you say pseudotensor, in this context, you're actually meaning pseudo-gravitational tensor
No,
specifically?
it's the pseudo tensor that he uses for the conservation laws for like the
Right,
what
but you're
was it
talking
the
about in
stress
terms of the
energy.
gravitational field. So, right,
S-
the end of that sentence is about his equation for his gravitational field and its material sources. So his pseudotensor for his gravitational field is a pseudo-gravitational tensor, or is it some other component?
The first one, the pseudo gravitational tensor.
That's the clarification I was looking for. Anyways, yeah, go right ahead, man.
Yep.
So Einstein's pseudotensor. Hence, if there are no material sources, then there is no gravitational field and no universe. That was in reference to the fact that gravitational energy cannot be localized. The best we can do is use the pseudotensor, which satisfies the condition. Condition 1, which is that when added to other forms of energy, the total energy is conserved, but not condition 2, which is that the energy within a definite three-dimensional region at a certain time is dependent of the coordinate system. And so, which in some special cases can be accurate, according to Dirac.
Shout out to Dirac.
Since the total energy momentum is always zero, the usual conservation laws for energy and momentum of a closed system cannot be satisfied. Thus, once again, there is no material source. Not only is there, or if there is no material source, not only is there no gravitational field, there is no universe, and Einstein's field equations violate the usual conservation of energy and momentum for a closed system. The cosmological constant, however, falls afoul of De Sitter's empty universe, which possesses space-time curvature but contains no matter, and is therefore physically meaningless. Einstein's field equations, in the absence of matter, once again, have no physical meaning. So, getting to the numerical perturbation. So, typically, we would be reading like the whole paper. This paper's 25 pages, so that's why we're not reading the whole paper tonight, by the way, if anyone's wondering. Numerical analysis of merging black holes and perturbation of black holes are ill-posed procedures for the simple fact that such mathematical means cannot validate a demonstrable fallacy.
Dude, how about
Simply no
that?
amount of
They just commit mathematical fallacies, bro. Not only is it derived like, from fallacious reasoning, but it's expressed mathematically through fallacy. It's almost kind of like poetic.
goes back to that whole role play thing.
It's
It all being a big role play.
Dungeons and Dragons.
This is how a scholar says another scholar is pulling it out of his ass.
Yup. Since the premises are false and the conclusions drawn from them inconsistent with them, such numerical and perturbation procedures are consequently of no scientific merit. Nonetheless, the LIGO Virgo collaboration has stated, let's see here. It matches the waveform predicted by general relativity for the inspiral and merger of merger of a pair of black holes in the ringworm of the resulting single black hole. Go ahead and highlight that. Since GW150914 was extracted from a database containing tens of thousands of numerically determined waveforms generated on the false assumptions of the existence of black holes and gravitational waves. So I don't know why I highlighted that, but not what it was in reference to. That's funny. No evidence for the disagreement from general relativity. What do you know? It's unfalsifiable.
Yep. Who'd have thunk it?
With such powerful computing resources and so many degrees of freedom, it is possible to best fit just about any LIGO instability with an element of its numerically determined waveform database. This is indeed the outcome of LIGO Virgo collaborations, as they have managed to best fit a numerically determined waveform for and to entities that not only do not exist, but are not even consistent with general relativity itself.
This is the numerical equivalent to NASA digitally cloning clouds.
Yeah, that's a good way to put it. There are no known Einstein field equations for two or more masses, and hence no known solutions thereto. General relativity cannot account for the simple experimental fact that two fixed suspended masses approach one another upon release. It is for precisely these reasons that all the Big Bang models treat the universe as a single mass, an ideal indivisible fluid of uniform macroscopic density and pressure that permeates the entire universe. Conclusions. LIGO did not detect Einstein gravitational waves or black holes. Black holes and Einstein's gravitational waves do not exist. They are not even consistent with general relativity. The LIGO instability has been interpreted as a gravitational waves produced by two merging black holes by a combination of theoretical fallacies, wishful thinking, and conformational bias. My bad. Black holes are products entire of violations of the rules of pure mathematics. General relativity is riddled with logical inconsistencies, invalid mathematics, and impossible physics. The general theory of relativity cannot satisfy the usual conservation of energy and momentum for a closed system and is thereby in conflict with a vast array of experiments, rendering it untenable at a fundamental level. LIGO is reported to have cost so far taxpayers $1.1 billion, just as is with the Large Hadron Collider at CERN. Such large sums of money would demand justification by eventually finding what they said they would. Oh, that's yeah.
All right, where's the video where they said they found it? We'll play that out, and everyone will know.
Oh, you want to watch
They,
that?
they
real
definitely
quick?
found it, and all that money was well spent. Yes, absolutely.
Ladies and gentlemen, we did it.
All right, hold on.
Talking about how they fucking
found it.
found a gravitational wave 2 days.
They did it,
found
man.
Yep, on Einstein's birthday or whatever, like the 100-year anniversary of what was it, special or general relativity? I can't remember, but
I think it was special.
no, just general.
It was just general. Okay.
100, because it was in 2015, 100 years, 1925 or 1915 was general relativity.
How
Anyway.
convenient that on a 100-year anniversary they'd made such a groundbreaking discovery.
Right.
What providential luck they have.
Yeah.
One must say.
Let me know when you guys are ready, and I'll play
Yeah.
Go for it.
Send it.
the big moment here.
Ladies and gentlemen, we have detected gravitational waves. We did it.
Woo!
And heck, while we got everybody here, let's
Dude.
go ahead and
We landed on Mars too. Oh wait, no.
I just missed it. Do it again, man. 13 seconds.
Ladies and gentlemen, we have detected gravitational waves. We did it.
Hell yeah, brother. That's what's up.
Oh man,
Science,
I almost
baby.
spilled my popcorn.
I believe it.
so tonight we were reading this paper, but a week from Tuesday we're gonna do another bigger thing about LIGO. We're gonna go into more detail about the larger scope of it all and the convolutional neural network that they use to analyze the data. So that's what this
I love
is.
CNN. Let's go.
Who knows what we'll see?
Computed abstractions. That's awesome.
And Matt's templates.
Holy mackerel.
I think it's funny that they call their data noise. It's like, so here's what we're going to do. We don't have any data, but we're going to invent a convoluted, self-serving, self-iterative neural network that'll interpret this non-data. And from that non-data, we'll extract this data that matches our predefined model. And then we'll claim that this data corroborates our model later. That sounds crazy.
Whatever they're measuring comes through a computational statistical framework. And so they're not actually measuring anything direct.
And then to get into the mathematical derivation of the so-called gravitational wave, Crothers also points out that under transformation, it's not even covariant. So like they try and relate it to it propagating at the speed of C, to match Einstein's theory.
Yep.
But they derive it in a preferred coordinate system so that it gives the appearance that it matches. It breaks down the transformations and it's not invariant under transformation. So it's not even covariant. It's not even canonized in the mythology and the mathematics. So it's like these people have a model that they, want to get out of this, and they have, the means and technology to scramble noise and dissect it through convolutional neural networks to get the quote unquote image of what they need of two black holes merging, little coalescing in the sky.
How cool is that?
Nice promo.
Smooth editing.
Nice promo, bro.
Dude, that's an epic trailer.
Dude,
Thanks,
that's like
yo.
the whole round table right there. I'm pumped.
I didn't even know I was in that one, actually. That's awesome, dude.
But what's up, y'all?
What up?
Awesome, man. Dude, honestly, like, all right, when you hear like convoluted neural network that repeats and interprets data as noise, from which we've generated non-noise, which we've then interpreted to the predetermined geoidal, gravitational double wave. Like, when you hear that, you go, that's a bunch of bullshit. Like, anyone would have to say that, right? Like, come on.
Nope.
My God, people relish it, dude.
People will be like, yeah, what's wrong with that?
They're like, I'm the bullshit veteran. I know what all that means. How much of that bullshit did you know? I need more. What?
The insurmountable problem for the credibility of LIGO's claims is the questionable character of the theoretical assumptions upon which they are based. Pretty well stated. A good paper. If anyone wants to check it out, when you actually want to, check it out for yourself, maybe do your own highlights or read it yourself. The whole thing. It's called "Critical Analysis of LIGO's Recent Detection of Gravitational Waves Caused by Merging Black Holes" by Stephen J. Crothers from 2016. I got a couple of new papers today about LIGO that I'm gonna be going through. That I imagine more of us will be going through. And then, yeah, like I said, a week from Tuesday, February 6th, we'll be doing a full on, like, just going hard on LIGO and what's going on there.
Wait. I was gonna say something like Ligonalation. I can't do it. I don't know. I was gonna say something cool, but it didn't work. What the fuck?
Well, yeah, this was a little bit of a shorter reading night. Usually these are a little bit denser and a little bit more monotonous, kind of, because we literally read papers. But I guess I don't know. We're still kind of feeling it out. This was only the third time. And I don't know. Thanks for putting the presentation together, Alan. And that kind of worked out to not read the full 20-something page paper tonight.
Yeah.
That was
I thought
very
so
good
too. Because like I said, it is a good read, but the important parts were extracted out tonight for the relevance of the presentation that's forthcoming.
And we got a couple new LIGO papers to go through, so that's cool.
Nice, a couple new convolutional neural networks to analyze.
So when I present these papers to the
Shane,
Gloomers to respect these,
did you know that there's a claim that the construction of LIGO actually had to account for the curvature of the Earth? So you know what that means, home dog? Someone out there dropped a plumb bob and had to figure out figure out if they were perpendicular to the gravitational equipotential that's generated by
geoid, then.
that's generated by the geoid, and they had to correct for that. So
Tough when using that geoid to find down.
It's really cool
relative to anything.
Yeah, it's really cool that's part of the mythology that they canonized that. So
I like that phrase. I really do.
Yeah,
me too. I was gonna say this.
It is mythology or like lore.
Yep.
They canonized their mythology. It's hilarious.
Yep. You can get a reciprocal
Well,
zinni
cool.
off that bad boy.
Should we close the streams out then?
Yeah, I think that's a wrap, man. Unless anyone has
Cool.
unless anyone has any questions or anything about like LIGO or anything.
Gravitational waves are awesome.
Check the stream chat.
We did it.
We did it.
I didn't know you guys were streaming.
Yeah.
All right, I'm closing out.
Yep. Sam. All right, guys. Have a good night.